Hello, in this class we are going to discuss about VLC as VLC stands for Visible Light Communication. So in today's class we are going to discuss about this is a new communication technology and the technology name as Visible Light Communication System. So this is new communication technology and it is using the concept of visible light. So in this the main aim that we will communicate with one another with the help of a media, and that media will be our visible light. Now visible light is only a small portion of electromagnetic spectrum. So as we have a complete EM spectrum, so this is complete electromagnetic spectrum. So that means visible light having a small portion out of the complete electromagnetic spectrum of the system. Now, what about the wavelength of this visible light? So, wavelength of visible light ranges from 380 nanometer to 750 nanometer. So, it ranges from 380 to 750 nanometer. So, out of the complete electromagnetic spectrum, the range from 380 to 750 will be my visible light communication. That means the wavelength of the visible light. So I can say that it ranges from 750 terahertz to 428 terahertz. Terahertz to 428 terahertz. Now this is the frequency and the wavelength of the visible light. So like 380 nanometer, then I have another one which is 750 nanometer, and in between this there lies visible light, and as we have like waveguide. So this is my visible light. So we will communicate with this visible light spectrum. That means out of the electromagnetic spectrum, we will use the visible light to communicate between one another. So the question is that why visible light communication? As we have shifted to visible light communications from RF, so why there is a requirement of visible light, or what are the advantages of visible light communication systems? So the question is that why visible light communication? The very first important feature that it doesn't cause any health problem. So first is so this become an important feature that visible light is not affecting our health. As RF frequencies or the electromagnetic frequencies are cancer causing frequencies that we are using in RF. So in order to protect the human health, we are shifting to visible light communication so that there will be no impact on the human health, like no cancer, no skin cancers, radiation. So we are using this so that we can protect human beings, we can protect birds, those who are getting concerned with the frequencies. Now, next one is that there is no electromagnetic interference. So interference is also less, or there will be no interference because of this visible light communication system. Now another one that it is free. We don't require to purchase the spectrum. It is a free source having a fast switching. So it's free. It is having a fast switching. Now ever increasing, like we have ever increasing market share of LEDs. So LEDs are easily available. Because we have a huge market of LEDs, so these LEDs are easily available. Next advantage is that it is safe to use in hospitals. This is completely safe to use in hospital, and another one is it's non-expensive. It's non-expensive in nature. So these are the various advantages of visible light communications. Like the very first, that it will not cause any health problem. So there will be no interference. As in RF, we have a major concern to protect the interference. So there is no interference. It's free, it's fast switching, easily available, and we can use in hospitals where there is requirement that the technology may not cause any problems. So these are the various advantages of visible light communication system. That's why we require to use VLC as visible light communications. So now we have a device, and that device is known as photophone. Now let's understand that what is this photophone. Now photophone was developed by Alexander Graham Bell. So this device is developed by Alexander Graham Bell and his assistant Charles Stanter in 1880. So this photophone device, which is developed by Alexander Graham Bell and its assistant in 1880. That means they have used the first method of wireless verbal communication. So this is the first method of wireless communication. Now used photophone for transmitting and receiving data. So this device is used for see that means Visual Light Communication Consortium. VLC Consortium was signed in year 2003. So this is in 2003, and this consortium was signed by Japanese companies. So Japanese companies has decided that why not to use visible light communication. So they have decided, or they have made a consortium for this, and by Japanese companies. So Japanese companies has made a consortium in year 2003, and now why? Because they required to standardize visual light communication technologies. So aim is to standardize VLC technology. They want to establish a standard for this technology. So in short, they are making a standard VLC technologies, and they also wants to avoid fragmentation of different protocol implementation. So avoid fragmentation of different they want to make this technology and standard, and also they want to make use of different protocols implementation. They want to make it fragmentation, avoidance of the fragmentation. Now what are the standards proposed? So we have a standards for it. Now the proposed standards are JEI-TACP 1221, and another one is JEI-TACP 1222. Now these are the standards which are proposed for visual light communication technologies, and they also try to raise awareness to the public for its uses. That means they want to promote it, and like what are the advantages of this, so that people can aware of becoming uses this technology as visual light communication technology. Now what is actually the technology is? Technology is actually that every kind of light source could be used as a sender. So remember that first point is every kind of light source could be used as a sender. So we can use every kind of light source which could be senders. Now we are using LEDs because they are prominent choice for transmitters. So light emitting diodes they are prominent choice for transmitters. So every kind of light source can be used as a sender, but LEDs are the prominent choice for transmitters. Now there is a switch off and on in every short intervals. Switch off and on systems for every short intervals. Now these are about like transmitters or the senders, that we can use every kind of light source which can be used as a transmitter or a sender, but prominent choice is light emitting diodes, now which is having a switching functionality, that means off and on for every. Now as per the receivers, like what are the kinds of the material that we require to use as a receiver? So for receivers, what we can use photodiode receivers. First one is that we can use photodiode receivers, we can use CMOS sensors. So these are the materials that we can use as a receiver in visible light communication technology. Now let's have a schematic view of sending and receiving the data. So this one is schematic view of transmission and receiving data. So like I have data. This data will undergo a process, and the process is what? Modulation. So this data will undergo modulation. So it can use modulation as PPM, pulse position modulation, and also it can use as FSK, as frequency shift keying. So this data after modulation will require to pass through a light source. So this is a light source which is used to transfer the data. Now at the receiver end, what we require? At the receiver end, we require photodiode or CMOS sensor that are used for reception. Now after that, I require to demodulate data. So the process as demodulation. We can use the method as above stated. And after that we have data. So this is a complete schematic view like how data will be transferred from one end to another end. So what we require for transmission and reception, we require some units. So for transmission we require a light source, and for reception we require a photodiode or a CMOS sensor. So this is a schematic view of transmission and reception of data that we require in our system so that it can work properly. Sorry. So visible light communication technology wants to use a system, and that system is a light source. So with the help of the light source as which are easily available inside the buildings, like we have a scenario that most of the internet access users are nowadays inside users. That means that inside a room or inside a building they are having access of the internet. Now as well, like we have to make some source, we have to make some technology that is providing the internet uses at high speed but inside the premises, inside the rooms, inside the buildings. So we are preferring the light source for transmitting data. So because light, each and every unit whether in a room or in a building require a light source, and there is easy option of light source available in the building. So we can transmit the data with the help of the light source that can be accessed by the users. But what we require 24-hour light access to the user whenever they want to access the internet. That could be easily available. So this is the motive of the visible light communication system, that they are going to use about the visible light so that they can give a speed up to 40 Mbps for the users. As we have LEDs, like those are known as phosphorus LEDs. Now this phosphorus LEDs can achieve up to 40 Mbps. That means with the help of these phosphorus LEDs, we can have 40 Mbps speed. Now we can use another type of LEDs that are known as RGB LEDs. Now these RGB LEDs can extend, that means the data can go up to 100 Mbps also. So we require to make powerful LEDs so that it can have the data access. Now another one is RCB LEDs. Now with the help of this RCB LEDs, that means resonant capacity based LEDs, they can give us a result as resonant capacity cavity. So these resonant cavity LEDs can extend or they can achieve data of up to 500 Mbps. So this is visible light communication technology is also one of the option to make this much data rate possible for the user. So in this class of visible light communication technology, we have the overview of this technology, like why we require it and how can we achieve it. So we will continue with visible light communication technology in our next class. Thank you so much.